Hey guys, now we're going to get into some real machinery when it comes to quadratics. This technique is known as completing the square, and it's a little bit more complex than the last couple of ways that we used to solve quadratics. But it's not too bad, and it's crucial for deriving the quadratic formula. All right, so we say a quadratic is square if it can be written as the product of the same linear factors. Meaning we have something like x squared plus ax plus b equals x plus r squared. Or that's just x plus r times x plus r. And so it's a square because it's literally the square of a linear term. And as an example, the quadratic x squared plus 2x plus 1 is squared since it equals x plus 1 squared. And we can see that by taking x plus 1, multiplying it by x plus 1. Foiling it out, we get x squared plus x plus 1. And that's x squared plus 2x plus 1. And there's actually a technique for figuring out explicitly which quadratics are square. So I was able to recognize right away that x squared plus 2x plus 1 is square. You guys were not expected to. But in this video, we're going to discuss how to tell how a quadratic square and how to take a quadratic and turn it into a square quadratic. All right, so if a quadratic is square, then its coefficients actually follow a pattern. And we can derive this pattern by just starting with what a square quadratic looks like. So say we have x plus p, and we square it. That's going to be x squared plus 2px plus p squared when we FOIL it all out. So what that's saying is that this middle term is twice the square root of the ending coefficient. And if we look back up at our previous example, we can start with 1. If we take the square root of it, that's 1 again, and then we double it and we get 2. So that's how we're able to tell that this is a square quadratic. Now we can use this method called completing the square to solve different quadratic equations. And what we're going to do is essentially just take our quadratic and force it into being a square. And so I'll show you guys what I mean in this example. So if we want to solve this equation, x squared plus 4x plus 2 equals 0, we'll start with x squared plus 4x and actually subtract the 2 to the other side. Now, we said that the middle coefficient, in this case 4, needs to be twice the square root of the ending coefficient. So we'll take 4, we'll cut it in half. That gives us 2. Oh my God, what is happening? I'm sorry about that. So we'll take 4 divided by 2. That gives us 2 back. And then square it. And that gives us 4. And so now we're going to take 4 and add it to both sides. So we'll get x squared plus 4x plus 4 equals -2 plus 4. And remember, if we add the same term onto both sides of the equation, that doesn't actually change the solution at all. Except now our left-hand side of the equation is a square polynomial. And we know that its factor is 2, because we're just going to look up at the pattern right here, where we can factor down to x plus p when we have that our quadratic follows that pattern. So we have x plus 2 squared equals 2. We take both sides of the equation and square root it. And then we just take our 2 and we subtract it to the other side. So we finally have our solution, which is x equals -2 plus or minus the square root of 2. And it's important that we can use completing the square here, because this isn't a friendly number to come up with on your own using. If we were to use the diamond method, we would have had to figure out that if you take -2 plus root 2 and add it to -2 minus root 2, then we would have got the middle term. And if we multiply them together, we would have got the ending coefficient. Those would have been two numbers that are really hard to come up with the diamond method. And we have a middle term. So that means that our difference of squares technique isn't going to work either. So completing the square is a bit more general and allows us to solve quadratic equations in this way. And because it's more general, it's actually going to be nice enough to let us use the same technique to derive the quadratic formula. And that will be the next video. All right, thanks for watching this one.